Hi everyone, thanks for attending the session. My name is Rida Laiji. I'm part of Nokia engineering team. Kind of picked today's topic about something that we strongly think is very important for the industry. And we're trying to the next couple slides, we're gonna go over the challenges of dealing with optimizations, peering automation and optimizations, as well as proposing solutions, and also going through some use cases. So we'll start by defining problems, some of the role and capabilities of an SDN controllers that are gonna play, what kind of added value by bringing SDN to that solution. We're gonna focus a little bit on the automation from not necessarily to setting up the network or programming the peering from scratch, but really automation to enhance and control and also optimizations. We're gonna have tons of use cases. We selected a few of them that we're gonna go through them. Some are for ingress, egress, but different flavors. We'll talk about either performance-driven use cases or optimizations, or inbound, as well as some other flavors of it. All right. So maybe stating the obvious here, but the key here is the last changes into the internet traffic, and not just the internet traffic, the amount of traffic that goes through, but actually the nature of the traffic, where a lot of traffic is concentrated for certain content. So with this kind of traffic or this kind of traffic behaviors is very unpredictable. We'll see a lot of spikes, and therefore we throw in another constraint into this is most of those content-based traffic or application-driven have their own requirement, their own SLA. They have specific need for, let's say, latency or other type of performance, or it could be an SLA, either a real SLA between the providers and the consumer, or something that internally that the application from technological point of view need to have to be able to function. So looking at all this, there's a need, and we will see later on in some of the use cases, to address that particular segment. So what we're trying to do here, or the objective, is really to have better bandwidth or better resources in general. It could be bandwidth, it could be physical assets, management, optimizations of what we have in the network. Also, again, better meeting internal KPIs or external SLA from network and optimizations based on what we said earlier about the traffic. It could be also reducing the cost, because those peerings have different costs, different models from one area to another, from one region of the country to another regions. So it could play a role into CapEx, OpEx as well. So what is the interest in this solution here? So it could be just an inbound kind of traffic, and that's actually what we have seen the last few years looking at this kind of solutions is, depending on your industry, you may be interested more in the inbound and nothing else, or may be interested into optimization in the edge or the egress part of it. In this case, could be latency, or could be congestions and so on. Or it could be, we have seen also cases where it's balanced, meaning that I want my inbound and outbound have certain kind of optimizations. All right. So you will see in the next few slides how we tackle this. But really the focus here either could be the peer themselves, or could be actually the peer and the network. The underlying solution, how we monitor, how we, like I said, leverage the SDN components, as well as the visibility, the analytics, the data we collect, the in-context data we collect, could be necessarily the same. but really what we act on is depending on the intent and depending on the use cases. So why we want to do this is there is, with today's technologies and today's way of deployment, there is certain limitations from, talking about visibility or performance, not necessarily not having the data, but making sense of the data and put it in a context. That's what we call visibility. Everyone collects, tons of analytics, tons of statistics, and so on. That's not the issue here. It's just put it in the context and really be able to explain it and put it what it should add value. You look also at organizations. Culturally, the pinning has its own challenges. So you will have different organizations. You may have a longer period of communications, what we have seen. You may also need some other external tools like, for instance, you may need to simulate something before you change. So there is delay, and it's most of the time is reactive mode, and chances that there's nothing happen and that the problem get elevated by the different traffic or different behavior of traffic. All right. So this particular problem or space, it's been addressed by, or what's currently being addressed by many of the players, depending on the industry. So some have chosen to do appliances kind of solutions just because of the need. Some have looked at their business and they realize that they need to apply software to it or analytics to it. Bottom line is everyone is looking for the end-to-end optimizations for that type of deployment. Very high-level solution before we go into details and into the protocols and technology that we leverage in this particular solution. Really, if you look at, like I said, the underlay infrastructure, which is the monitoring, the network control and monitoring, the real-time visibility of the network, put it in a context, and based on the intent that you want to do, are you want to do performance, or you want to do, for instance, elevate congestions, will be, have some priority traffic that you want to deal with. This get triggered to the real engine which does the automation. The intent here could be expressed by a REST API or machine-to-machine, or could be in operators after getting into a certain state machine that need to trigger that particular use cases. All right. So we're going to go into the details of the next use cases, and we're going to zoom in more into technologies, the protocol at play, as well as how do we extract the data and actually push it back to the appropriate selective point in the network.
Can you hear, or is it on? Okay. Thanks, Rita. So, so automation in general on the peering environment and optimization is not really a straightforward problem to solve, because there are a number of elements that may not give you the perfect solution or the controllable solution. So what we try to do is to see what are the set of use cases that are really realistic, that are coming from problems in a real field, and categorize them, and then understand what are the knobs that we can use and implement to realize these use cases. So in terms of challenges, so you can see, besides the fact that when you talk about automation, we as well think, maybe there are some human factor that's being involved, like, maybe reducing, number of players or numbers of employees. That's not actually the intent here. Is really to see whether we can make a better, efficient operation and the way we implement our networks today, given the new reality of traffic that Reda was mentioning before. So in a grand scheme of things, in the context of a framework, what what are the elements that influence that level of automation for the purpose of optimization? So you will need some level of analytics. Here we're talking really big data analytics, ability to collect beyond just statistic like prefixes, ASs, information utilization, interface utilization, but maybe go further is to do some level of correlation, like what traffic is running, which BGP routes are associated with which application. Having that information then pushes the fact that the mechanism to use to manipulate the traffic may be what we have today may be limited because it was designed for the years that we were doing, for example, traffic steering by manipulating 5 tuples or playing with route forwarding. So I will talk a little bit the use cases that deals with big data analytics and the telemetry aspect. But for performance, for those who cares about outbound traffic, which performance plays an important role, then you need a level of probing systems. And there are different mechanisms that are being used today and some as well being explored. You have ping, you have T1 for more precise, you have TCP, UDP that being used as well. Even on the network side, in-band type ONM capabilities. But in general, you need the ability to measure latency and to be able to factor that latency packet loss, to factor that into the algorithm of automation and optimization. And in fact, in systems that, in use cases as well, systems that solve that type of problems, the analytics is actually the driver behind what to probe, what information, what address behind to probe, and whether we get really the latency value or we get the closest point to reach that latency. And then the other factor is once we get that information, how this is the external across the internet, but then how to use that information to factor in how you perform traffic engineering inside the network. Instead of doing in isolation, today we see a lot of work that went into the traffic engineering on the IP and PLS network, decoupled from what's going on the peering environment. And maybe it's time to look at, and we've seen some use cases where it says, maybe peering, there's not much problem there, but the internal links get imbalanced. And then influencing the peering traffic will influence how traffic is being forwarded from the border routers to the internal networks. And depending how traffic is, how the routing and the path manipulation is being implemented. So you need some level as well of notification. Automation implies as well detection, auto-detection of the information, whether congestion situation reaching certain thresholds, performance, so the system has to be able to notify. And in this case, actually talking about statistics here is the fact that as well the rates start playing an important role, whether per minute, per 5 minutes, maybe how you run your cycle of the algorithm for automation. All these elements need to be factored in when we implement solutions dealing with automation. So I will go a bit, and there are other things that needs to be taken into account in terms of protocol. So what's important as well to mention is the fact that if we deal with, let's say, outbound traffic, so we will need to be able to have a wide range of ability to steer traffic. So we've seen actually situations where maybe manipulating BGP may not be the best option. Reconfiguring policies may not be the best option. Maybe using filtering capabilities may be the best option. But then using filtering may imply as well covering some functionality that BGP already covers. So that's why it's important in terms of realizing these use cases in terms of automation optimization to be able to have a wide range of mechanism protocols where we can act on the traffic, including the ability to program forwarding entries directly using an API. So router vendors open their forwarding plane, provide the API to be able to program, to be able to build applications such that we can go and for certain situations you don't want to maybe instantiate filters traditional ways to be able to directly influence where the forwarding needs to go. And that is, in fact, part of a traffic steering capability. Having the analytic component to it, having the information of the traffic, what type of traffic we're using, what application is being used, then we can build more macro type traffic steering. Instead of saying prefix and routes, we may be saying, for that application, I see congestion, move traffic of that application from one peering to another. That in itself implies a transaction-based type traffic manipulation. So you, in this case, that application will translate into multiple BGP routes associated with it. Then you need to move all these routes in a transactional fashion. So that type of macro steering, we didn't have it before because the elements, the knobs we were playing with were like prefixes, ASs, protocol-centric concept. While in the analytics, the knobs they play with are more the nature of the traffic we're using. So bringing the two together is really will push into revisiting the spectrum of mechanisms that we were using before, maybe extending them and doing more integration. So in a summary, really the challenge in automation optimization is about integration, really. Ability to integrate systems that were designed for their own environment, their own culture, their own objectives. And that's in fact a big challenge to break that barrier between the analytics, for example, where they build their expertise around understanding the traffic, and the networking side where we build our expertise, how we solve routing, reachability, what traffic engineering we use, what's the best path to pick. Bringing them together really requires some level of culture change as well. So integration plays an important role on this type of problem. So let me go through a set of use cases that are actually coming from the field. So one of the drivers we wanted to do this presentation is really to share with you the reality of what we've seen and discussed with a number of carriers, enterprises, and web-scale players as well. What do they care most? So we summarized in a couple of use cases. As a starting point, so you have situations like doing peer engineering for congestion situation. So automation or optimization using an SDN controller with an analytic engine that feeds that SDN controller with some level of information. One of them is congestion. Congestion, typically you pick it through getting performance stats, getting the interface stats directly, not flow stats, but interface stats, and then measuring, depending what rate you want to set your threshold, and then you given this automatic notification, you pick what destination, what alternate peer that has enough bandwidth. And then you pick that alternate peer based on the available bandwidth, and you want to be able, we've seen situations where the traffic that is moved, not necessarily congestion to a level of the AS path, for example. Pick a level within the AS path to move certain traffic. This is typically for enterprises that experience, they have some events and some events where traffic will go high, and they start to want to be able to pick and choose what traffic needs to be offloaded. So let me go a bit through. The second one is actually known in the IETF, the egress peer engineering, the ability to engineer a peer and an egress peer link from a given edge router. And typically you will have different techniques here as well. Segment routing plays a role here in this type of mechanism. The difference here is that the fact that when on the PE side, we've seen that for those who manage content as well. When they get that peering get removed or drop in terms of traffic or high traffic, they want to steer certain traffic to alternate peer. We know what the mechanism to play in terms of how we implement it. We know you need some level of getting the topology of the peering, discovering the LSPs or creating new ones. But little have been said how the analytics play into that model. So in this case, if you had some level of analytics, you will be able, in the peering context, we will be able to traffic engineer the tunnel that you offload the traffic according to what we observe on the peering. Instead of blindly picking, which LSP and how much bandwidth that LSP will shift traffic on the provider edge to an alternate peer, and overriding the default BGP route, the BGP path. So in this case, if we had an analytic engine that gives us the nature of the traffic we want to offload, how much that traffic and what type of traffic, then we can guide the parameters of the traffic engineering to fit that model. If you want, the exposure for the EPE, even in the context of, let's say, segment routing or even normal MPLS, is the fact by overriding the BGP selection and the default route on a PE, in fact, we're not taking advantage of the BGP capabilities. If the route gets redrawn, you want BGP to be able to, you don't want to disrupt that mechanism. The EPE in that particular context may disrupt. So the solution has to take into account the failure condition, the corner cases, to address them. And that's important when you do some level of automation in this case. And then in this case, the controller will start owning some functionality that's already, in fact, better handled through existing protocols that we use. So it's not like all or nothing and move everything to a controller. It's really what part of the system of the SDN part that complement what we have today, instead of just replacing and centralizing all functionality. So. Yeah, so the latency part. So let me talk a little bit about these are all the three use cases about outbound traffic typically. So the latency part is as well, you see them in the financial type institutions where they want to be able to send some traffic, pick always the best lowest latency to reach certain destinations. And example, financial gaming as well. And depending on the approach that they took, how they architect as well, some they go even further, re-architect their network to fit really their main requirements. So in this particular case, so the idea is really to probe for packet loss and latency from a border router to the external address. There are already solutions in that particular space. They have appliances, they probe, and then they inject BGP routes or policies to shift certain traffic from the default peer. But what's the difference here is the fact that information has to take into account that probing information has to take into account the measurement of the inside of the network. So if you have a network, typically the previous solutions, if you want, were just looking, because we had this boundary, because operating the internal network decoupled from the peering one has created that type of imbalance. So if you do probing from the border to the external, you may want to be able to, and those who do probing internal, let's say an LSP ping, for example, to measure their latency, you want the path computation to solve the problem, what's the best egress peer to pick for certain destination based on latency. That path computation has to take into account the end-to-end probing latency information. So that has to take into account the end-to-end measurement. So you measure the whole thing and let the path computation inside the network. And then in this case, you will see that an SDN controller add really value there, because you will be able to discover the LSP or even create a new LSP through PCE-initiated capabilities and traffic engineer that LSP to fit the alternate peer, that we pick. So the key thing is really the path computation has to take that into account. The other dimension to it is the fact that when you need to be able to do in the context of automation is to pick the traffic that we select, let's say, an application that we want always to have lowest latency and steer it to the alternate LSP. So if that LSP fails or anything that fails, the system has to recover itself, has to be able to remove the flows or remove the routes, and has to be able to, to pick a new one and so on. Then in this case, you don't want a system to be able to flip-flop because of lowest latency. You need to build into the algorithm a tolerance level, a delta level. If, let's say, if latency drops to a certain level, then start running a recycle of the automation mechanism. So let me, last set of use cases, or let me talk about another one important use case, controlling inbound traffic. This is an area that doesn't really have perfect solution if you want. Controlling inbound traffic is of interest. Mostly, I would say, a lot of service providers today with the nature of traffic, they receive a lot of traffic and they experience congestion situations. Some of them as well are driven by cost of the peering or the transit provider, and they want to reduce costs. So how can we do better controlling inbound traffic using some level of SDN controllers or automation? In this case, the solutions are a bit limited, in fact. The knobs that we can play with are a bit limited, are well known within the environment. So what, the BGP knobs typically, that's how we influence, because we want to influence the neighbor decision process. But what I wanted to mention here in the context of inbound traffic is the fact how the solution, how today we operate this, we implement it beyond just the protocol knobs. So you will see different models. To do a good automation in that space, we need to identify what model is being used, how the operator is influencing the inbound traffic. A number of operators are using communities, for example. These communities, the deployment of these communities to effect the change on the border routers don't happen at the border router. They happen before reaching even the border, at the PE level, if you want, at the edge of the network. And then in this case, a model built around community will facilitate, in fact, automation, because now it becomes like how you have the view of the network. If you have the community members, that community, you need the automation system to build semantics of that community, to understand semantic. For example, for that community member, it means that the border router will do an AS prepend and making the route less preferable, for example. That model number of operators have implemented this type of mechanism. And this type of mechanism, we can achieve some level of automation with some, when it is in a controlled environment. And that automation can be, if you want, what's called really as well known as the autopilot mode. In other words, no operator intervention. But the moment you start touching the protocols, then you will be like having dual environment, and you don't want that. So in that model, when you manipulate communities and move communities here and there, is to be able as well to take into account the ability to preserve the functionality. If you move, let's say, some communities to some peering links, then in this case, you want to be able to preserve ECMP, you want to be able to multi-home, then the automation mechanism has to take into account decision beyond what we were doing before. So this community will as well experience AS prepend, not for the purpose of the normal BGP operation, but it's for the purpose of achieving meaningful type of automation. So the other level of controlling inbound traffic, we've seen it as well, is when a number of operators will say, we want some level of abstraction automation, but we want to be able to trigger the change. We don't want system to fully automate. Then the system will have to maximize abstraction instead of making decisions on what to route traffic. So that's another level of automation. So let me so we included the slide here to show, somehow for the operator triggered change, in the example of communities here, how they influence the border routers. And in the case of automation, why we put actually this slide is to mention the fact that we observed the way folks have implemented how they manipulate the peering environment is they do some regional, not just the peering, but with the edge of the network, they segment the network in a region according, not necessarily for routing purposes, but for identification purposes. And they want some of that to keep the automation optimization within the same region. So let's say they want to build hierarchy in terms of how the automation should work. For example, start with the same router experiencing problem, go to the routers within the same site, and then if cannot solve the problem, go now to different peer on a different region completely. And in this case, we're calling it here slice type, or it can be zoning or some level. That's not congruent to the routing infrastructure. So then the automation start to be a bit, or if you want the optimization start to be running different, you need some regional type optimization mechanism built into the solution. So another one for outbound actually traffic is there are those who can host content, and they have like gateway routers, uplinks these gateway routers. They want to be able to say they have some bandwidth for, let's say, metro network, not to they're connected to their core, but then they have some metro network that they have some bandwidth, but not enough to handle all the ASs that they have in their environment. So in this case, I want to monitor outbound traffic for the uplinks and understand the AS consumption, utilization bandwidth. So we need to get flow stat on destination ASs, and then pick and choose which AS to offload to a metro. Pick and choose which AS is pick and choose which all the subnets associated with that AS. And then solutions like that will require acquiring the BGP routes, all of them, not just the one that's been selected, and be able to wrap that AS. When we steer that AS, we steer all these routes. And in this particular case, the steering is done outside the BGP. So there are operators that they want to use these use cases and these solutions only for exception situations, not for like the normal operation, if you want. Okay, so maybe tough time. So in summary, so what we wanted really to highlight, given this talk, is there are a number of challenges, technical challenges, non-technical, in fact, challenges. But there are solutions. So if automation works, automation optimization works, if we can control how it is being used today, how we understand really the knobs. Some of the knobs can be controllable, but it's not all. Some of the operations it doesn't add a lot of value to automate them because you're doing it already. Like, let's say you see a problem, you go to and you perform an AS prepend, for example. You may automate the protocol to push these changes, but it's not really truly automation. So the automation is really implies, orchestrating between the control part that's peering and internal of the network as well. So I already mentioned the multidimensional traffic steering by using more advanced data analytics. The challenges as well is this type of use cases as well operates in a brownfield environment. So there's existing network already. It's not like you're building greenfield network and say let's do automation. And the challenge with that, you'll be dealing day one with scalability. It's not something that you can delay. Scale, you cannot delay it for this type of use cases. If you want to automate, let's say, an AS, destination AS, you'll be dealing with a network that may have like 300 ASs, 2,000 prefixes per AS, and you have a large number of uplinks. So all this, and you need a rate less than a minute, for example, to collect all this stats. So the challenge for these use cases is not like we solve the functionality and we solve the deployment later on. We solve, in fact, deployment day one before even hitting what's best functionality to pick. So as I mentioned as well, the last part is the challenge as well not to disrupt, so I'm almost done. So not to disrupt the existing, not to disrupt, to complement what we have versus replacing. And especially for the situations of recovery, for example. Let BGP do what it does best. Let's not try to build functionality in a controller. At the end of the day, it's already been addressed by the protocol in a better way. So complement versus, replace. And I think that will work better for automation and optimization in general. So I think maybe over time here, so if you guys have any questions.
So we actually don't have time for questions. We're over.
Yeah.
So. But thank you very much.
Thank you.
Thank you.